All right, class, how you guys doing? So we're going to continue on this math models worksheet 4.1, okay, relations and functions. Remember, we broke it down, and I kind of wanted you guys to take it into little pieces. So what we did first is the first lesson was determine whether or not the coordinates, whether the graph, the dots, are functions, right? And the graphs, there are functions. That was day one. And then day two was, okay, let's determine the domain and the range of just the scattered points, right? And the coordinates, right? Let's just find the domain and range. And now we're going to do the same worksheet, but now we're going to focus on what? On the domain and range, but for the graphs, okay? The graphs. And where are they? Oh man, I can't believe it. I thought I had, oh, here they are. So now we're going to determine the domain and range of these graphs, okay? So we're going to go ahead and start, okay? Again, the objective is given a continuous graph, right? Determine the domain and the range, a continuous graph. So let's go back and just remember what we did, okay? What is the inequality for this line number, okay? For this line number, well, if you notice, anything that's horizontal, usually the x, right? So that's why people use the x, all right? So we're going to go ahead and, well, let's take it bit by bit. So we're going to go ahead and determine the inequality for this. So the inequality for this one is what? Is what? Oh, x is, we're going to use 3, but it's all the, ooh. Yeah, so we're going to basically need all the numbers that are smaller because this line is going to the left and the numbers are getting smaller. So they're smaller than and equal to 3, right? They're equal to 3 because it could be 2.99, 2.98, 2.98. It doesn't have to be 2. It could be 1. It could be 2, all right? And then we're going to go ahead and cover this terminating point, and we're going to find the inequality for this line. So basically it's x and it's going to the right, so that means it's greater than and equal to, right, because it's closed, and -2. So we're going to put -2 here. So -2. So in order to put it in one inequality, we got to redo we're going to flip it around. So now it's like that. It looks like that. All right? Cool? All right. The next type, leopard. So on this one, again, it's a horizontal line, X. You can use R, but technically a lot of people like to use X. So we're going to go ahead and put, but remember, there's only one terminating, okay, dot. The other one is infinity. Infinity and beyond. So there's no two terminating points, right? So this one's going to be pretty easy because x, and I'm going to use all the numbers -2, so all the numbers that are bigger than -2 and equal to -2. All right? So can I use 100? Yeah. All right? So that's kind of a review of what we've done. And all this is now is the concept is basically telling you this. All right, if we have a line, all right, so we got this line right here, all right, with an arrow. So now we're gonna create this line on the grid. So let's say it's there, but let's say I want to go ahead and put it on this grid, right? And now I'm gonna just create a different design. So I still want to do with -2. So I want to create a different design. So it's going to go this way. All right, so I'm just going to make it up, and then we're just going to say, okay, it's right there. And then the line goes vertically like that. And with the arrow, okay? So now what we want to do is determine the inequality, determine the domain and the range, all right, of this continuous graph. So what we're going to do is remember, um, first is the x, then the y, right? Then if you put dr, that's doctor. So that's a good way to remember. So your domain is always the x. The x's only, okay? So if you notice this line, okay, what is your minimum? The smallest x. So here you have this line, and if you go basically on the x, da 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 da, this is the smallest right here, right? So when x is -2, see that? X is -2, because technically it could have been a straight line horizontally, but we just shifted it, all right? And they're trying to confuse you. Don't let it confuse you. Don't let it confuse you. Don't let it confuse you, because you're better than that, all right? My name, oh. Oh, ba da da here we go, all right? So there. So now, what we want to do is, how do you determine the domain? Well, we know it's -2, so x, but it's going all the way to the right, xx, because right here it's 3.5, comma, and then -3, 5, comma, this, 6, comma, that, right? Because it's a continuous line, so it's basically any number x that is greater than or equal to, right? Because it's a closed point, and it's greater than or equal to, and equal to -2, all right? Because it's a continuous line. Good? Now, what about range? The range, okay? So now the range is a little tricky, okay? The range is now your what? Yeah, your y. Right here, your y. So now now you're gonna look for the y. Here's your y. Y. Right here, the 3. So the highest, the maximum y is 3, right? Right here. So -2. It's not 4 because there's nothing else over here. There's nothing over here. So it's -2 comma 3. So the y, we're looking for the range which represents the y. See that right here? Right? Got it? So then I want y is what? If we're going to use all these y's going down, look at the numbers are getting what? Bigger or smaller if we're going down, right? Yeah, they're getting smaller, so it's less than or equal to or unequal to 3, right? Because look, right here we're going to use 1 comma -3, 2 comma, 1 comma 0, 2 comma -1, 3 comma -2, 4 comma. So you're going to use all these y's, right? And they're going to be smaller than 3, all right? So that's it. More. So we're going to do one more problem. So remember, when you have a continuous line, it's going to look like this pretty much. It's pretty simple, all right? But, mister, well, what if they don't have continuous line like this? What if it's just two terminating points? Oh, okay. Well, let's do a problem like that. So what do you mean? Well, let's see if let's say if you had this like this, and then the line became all wiggly, 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 but you had two endpoints. Oh, so you mean like this? Let's say right here. Do you want a closed or open? A closed. All right, let's do closed. Right, and let's do a wiggly line. A wiggly line, and then right there, and then shall we close it? Yeah, let's put a 5, and then we'll close it right there. Bam. Okay. No, let's just put a continuous, an arrow. Okay. Oh man, who's that? All right, so now what you want to do is you want to find the domain again. That's your x's and your range, which is your r. Okay, x. First the x's. Okay. So now here we're going to look on the x's, all right? So it's a continuous line, so that's going to go on forever. But what other x can we use? What's the minimum? Oh yeah, right here, -3. -3 comma 1. So my x is -3. So I'm going to use this number. So I want all the numbers, and this line is going to go right, 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 right. It's going to go down, up, 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 up. See, I'm using all the x's, but they're greater than and equal to -3. You see that? Greater than or equal to -3. All right, now this is where we becomes a little trickier. All right, we're gonna use y to find the range. Don't worry, it's not gonna be difficult. All right, so here we go. So now you want the y's, right? So the y, this is my y. Okay, so look at the graph. Okay, what's your maximum point? Right here. This is your maximum point right there, right? So the y is what? 1.5.4. So we're going to use 4. And what's the minimum? Well, the minimum, there's none because it's infinity, right? So wow, this is going to be a little tricky, but it's not, right? Because it's going to go all the way down. So basically, you want all the y's that are what? Smaller, because look, you go down, they're getting smaller. So smaller than and equal to what? Yeah, 4. And that's it. That's it. All right? That's pretty easy. Okay? Very easy. All right, so now, bam. So now, what if we have, yeah, what if you have two terminating points and a squiggly line? Okay, well, let's try that. So let's do a terminating point right here, right there. And then let's just put a squiggly line. And then let's put an open circle right there. Let's go actually a little bit further down right there. Sorry. Right there. Okay. So now what we want to do is find again the domain and the range. Doctor, right? X, Y. So first let's find the X. So here we go with the X. So here we go. So let's look at the number X's. Look at all the X's. So we're going to have -3, right? Because that's going to be this point, and 4. So I'm going to put X. I'm going to put -3 and 4. Okay, so let's take one at a time. So if we're following along the continuous graph, okay, X is going to be smaller, right? Because right here I'm using 3.8 comma this. 3.1, this point right here is 3.1 comma this. So all these X's are getting smaller than. Is it also equal to? No. So we're gonna have the bar on the bottom, the little equal right there. All right, so we're good. So now we want to do this one, and I'm gonna do it on the side because we gotta flip the inequality. So now here x. Now we want the numbers here. If I use this point, right, -2. This point, -1 comma this. So the x's are getting bigger than, and they're equal to, right, -3. And that's it. But in order to put into the inequality, I gotta flip it. All right, not flip it, but turn it around so it's gonna go like this. Got it? Got it? All right. So that's your domain. That's your domain. Now let's look for the range. Now remember, the range is another beast. That's beast. Okay. So that's your y. Okay. Here's your y. So I'm going to put y. So now let's look at the y's, all right, and look at the graph. What's the highest, the maximum point? Well, let's pretend it's 3, okay? Well, we could put 3.5. That's fine. Right here, right? That's 2 comma 3.5. That's the maximum, all right? So 3.5. Let me put it right there. And what's the minimum? The minimum, it's over here. It's over here. So this is like 4 comma -4. So it's -4. So now let's determine the inequality. So y, so you're going to use all the numbers going down. because it's on the graph, that are smaller than, right? Smaller than or equal to 3.5, because it's including, it's on the line, right? And then the y over here, hold on. On this one, you want them, all the y's that are what? Bigger. So it's trapped. It's in here. All right. So you want them to be bigger. So y is greater than, is it equal to? No. So it's open, -4. So now what I got to do is I got to flip the inequality. Go ahead and flip it. Right there. There you go. And that's it. So just keep an eye on the inequalities, on the range. Let's go ahead and do one. One for you. Where is it? Where is it? So I kind of did one already. Okay. So I kind of did this one. So just be careful, right? Just be careful. Some have terminating points, some don't. So in this one, it does right here. And then right there. Okay? So basically, here's your x. So x, right? What's the furthest? If I go down the line, it's right here when x is 7. And what's the smallest? It's what? -5, right? So x is smaller than and equal to 7. You want all the numbers that are smaller and equal to 7. And you also want the ones that are bigger than or equal to -5. So remember, you got to flip the inequality, and it looks like this. Good? Bam! So now this one, I made a mistake right here. This should be y, because that's your range. The range is a y. So right here, so you can start from here, and then you go high. What's the maximum of y? Right here. So your y is 9. You're going to use 9, and the minimum is -9 right there. Okay, the minimum. So basically, it's y is less than and equal to 9, and y, I'm sorry, this should have been y, is greater than. It's greater because they're going up. These numbers are bigger than -9. I want to use all these numbers, all these y's right here. Okay, I want to use all these y's right here. Bam. Okay, so then I got to flip the inequality, and it's going to look like that. All right. So just be careful. Like this one has, it doesn't have the arrows. So just, you could terminate them right there. Bam. Right here. Look at, just be careful if it has arrows. Like this one doesn't have arrows. So just put, this one has a circle. And I think this one has a circle too. All right. Right here. Does it have arrows? Yeah, you could barely see that they're arrows. All right. And then right here, look at this one here. Are there arrows? No, those are terminating points. Terminating points. How about here? Yeah, that's terminating points. We'll just put a little dot right there. That's fine. And then I'll go ahead and go over the answers tomorrow. All right. Let's look at these. Okay. This one. No, right? This one has arrows. See that? Arrows. 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 All right. So just pay attention. All right. Cool. All right. That's it. I'll go over the answers tomorrow. Here we go. Try it on your own. Repeat it. I'm going to add another link to another guy that did this. All right? All right, man. Take it easy. Woo! Yeah.